In this lesson, we're going to be talking about translating between the English phrases and words, statements, and converting them to algebraic expressions or vice versa. So it's important that we learn how to equate words or phrases with the indicated symbols of variables and numbers and operations in algebraic expressions. So make sure that we understand basic terminology that we come across in a English statement or a phrase using words. Within the four separate operations, addition, subtraction, multiplication, and division, there are key words that we need to make sure that we're familiar with. So in addition, if you see the word sum, that's going to indicate addition. If you see the word total in a phrase, that also would indicate addition. More than, if you see that, added to or increased by. Of course, the word plus, all these would indicate the operation of addition when we see them in an English statement or phrase using words. So we have two examples here. We see 4 added to a number. That obviously means to add. A number would indicate any number. We don't know what number that is, so we would need to represent that using a variable. We might use the variable n, for example, to represent that number. And it says that 4 is being added to that number. So we would write the expression n plus 4 for the phrase 4 added to a number. Then we also have here 7 increased by a number. Increased by indicates addition. So we would have 7, and that is being increased by a number, or 7 plus n. So that would be our expression. Subtraction also, we need to understand that if we see the word less, that's an indication of subtraction. If we see the word minus, of course, or decreased by within the phrase, the difference of two things would indicate subtraction. Or if we see something is less than something else, that is indicating subtraction as well. So in the examples here, we see the difference of 5 and a number. So the difference between those two, you have two parts to this, 5, and then your number n, and we're looking for the difference between 5 and the number. So 5 minus n is the expression for that phrase. We also have 8, less than a number. Now with this one you have to be careful because it's 8 less than a number, so we actually start with the number, or n, and it's 8 less than that. So it would be n minus 8. If we were to write 8 minus n, that would be incorrect. So we have to be careful with that. It's 8 less than a number, so you're starting with a number, and it's 8 less than that. So n minus 8 is the correct way to write that. This would be incorrect. So be careful with that one. And then we go to the multiplication. You see the word here, product, would indicate multiplication. If you see that in a word phrase, times, of course, or multiplied would all indicate multiplication. In our examples, we see here the product indicating multiplication, the product of a number and 12. So the two things we're multiplying is a number n times 12. Now, normally we would write our coefficient first, so we'll write 12n. That's the expression that would indicate the product of a number and 12. Doesn't matter what order you put them in, because the order of multiplication based on the commutative property of multiplication doesn't matter. And then we have the example of a number times 3. So again, it's a number n times 3, but we would write the coefficient first, so we would write 3n, our expression for that phrase. And then division, you have quotient indicates division. Of course, course, divided by, or a number divided into something else would also indicate division. Here are examples. The quotient, indicating division, of a number and 6. So it's a number and 6 are two parts, and it's the quotient of those two things. So a number n divided by 6. That would be the expression for that phrase. The second example, you have 10 divided by a number. So 10 divided by a number would simply be written like that, as that expression. If you had 10 divided into a number, of course, then you would have a number and then 10 divided into that. So again, be careful of the phrasing there. Let's look at some examples. Letter A says y increased by 12. So here we would have y, and that's increased by 12, so it indicates addition. Y plus 12 is our algebraic phrase. Letter B says the product of x and 4. Product, of course, indicates multiplication. And so if we write our coefficient first, we would write for x, or 4 times x. It's the product, indicating multiplication. With letter C, it says 8 less than the quotient of m and 15. So there's several parts here. So let's first of all think about we have a quotient that indicates division. Well, it's the division of what? Division of two parts. You have m and 15. So it's the quotient of m and 15. So it's m divided by 15. And then it's 8 less than that. So if we subtract 8, you'd have the quotient of m and 15, and then 8 less than that would be indicated by this algebraic expression. So it seems a little bit backwards, but you have to be careful with some of that phrasing. And then letter D says, James is 6 years older than Lydia, who is X years old. Write an expression that shows James's age. So Lydia is, we'll say, X years old, but then James is 6 years older. So that's going to indicate addition. James is Lydia's age plus 6 more years. So X plus 6 would be our algebraic expression representing that. Again, let's look at some examples here. These are already in algebraic expressions, and we need to write them as word phrases. There's many different answers you could give here, but with letter A, you have m plus 7, so you could say a number plus 7 might be one way to write that. You could also say the sum of a number and 7, or 7 added to a number. There's 7 more than a number, so there's various ways we could write that. Letter B says, gives us y minus 9, so you might say the difference, maybe. The difference of a number and 9. So there's, again, different ways we could say this. You could say 9 less than y, and there's just different ways that we could write this in a word phrase. Letter C, you have 5 times n. You might say the product of 5 and a number, for example. Letter D, you might say the quotient of x and 3, or x divided by 3, or 3 divided into x. Those would all be examples of how we could write that out in using a word phrase. Letter E, this one's tricky. You've got a couple parts here. You've got the product of 1/2 and 18, and then that is being subtracted from 27. So you might say something like the product of 1/2 and 18 less than 27. So there's different ways we could write this, but that's one example. Now, in this last example here, we have, let's see here. It says Janie is saving money to buy a car. She has X dollars saved and is saving Y dollars per week. So this is the amount of money she's saving per week. She has X amount saved already. So it says to write an algebraic expression to represent the total amount of money she'll have saved after 52 weeks. Well, she already has X amount saved. So let's write that down. And then she's going to save an additional, and so that's obviously going to be a plus, an addition sign. And she's going to save a certain amount per week for 52 weeks. So if we take 52 weeks times how much she's going to save per week, which is Y, the letter Y represents that amount. So 52 weeks times how much she saves per week added to how much she already has, this will be the algebraic expression to represent how much she'll save after 52 weeks towards her brand new car. And wouldn't you like a car like that?